Hello everybody. Today we're going to continue exponential functions and writing an equation from a table. We're going to do an example to start, which is making a table for this equation, just so we can see how it works. Alright, I know we did tables yesterday. This one's going to be a little more in-depth. Okay, so the first x value I'm going to find is 0. You can choose any one you want to find. It's good to start with 0. And the way I'm going to figure this out is by plugging in x equals 0 into this equation. So when x equals 0, y equals 4 times 2 raised to the power 0, where we replaced x with 0. Now if you remember, anything to the power 0 is just 1. So 2 to the power 0 is 1, and 4 times 1 is 4. So when x is 0, y is 4. You can see that is why the y-intercept always happens when x is 0, because anytime you put in 0 for x, the multiplier term gets knocked out. So we can continue this way. Let's try 1. When x equals 1, y equals 4 times 2 raised to the power 1. And you know that 4 times 2 to the power 1 is just 4 times 2, and that's 8. Any number to the power 1 is itself. And let's keep going. Let's go all the way to 4. Okay, so when we plug in 2 to this equation, let's see what happens. When x equals 2, y is equal to 4 times 2 raised to the power 2. 2 raised to the power 2 is just 2 times itself, right? Because that's 2 squared. And if we group these together using the associative property, we know 4 times 2 because we already did it up here. That's just 8. And 8 times 2 is 16. So 4 times 2 is 8. And then if we multiply by 2 again, we get 16. So you can see that in each of these terms, we're just adding on a multiplication by 2. And let's see if that pattern continues. When x equals 3, y is equal to 4 times 2 to the power 3. And 2 to the power 3 is 2 times 2 times 2. That's 2 times itself 3 times. Now we already did 4 times 2 times 2. 4 times 2 times 2, that was 16, right? So this is just 16 times 2. In other words, it's the last term multiplied by 2. So I hope you can see the pattern by now. Let's point it out. The y-intercept is 4. And that happens where x equals 0. The multiplier is 2. And the way we see the multiplier in the table is to get to the next term, first, second, third, fourth, you multiply by 2. So you can make a prediction and see that the next term, when x is 4, y is going to be 64. Another example. Now we're going to do the opposite. Find the equation of the exponential function represented by the table below. We're looking for something of the form y equals a times b raised to the power x. Let's find the y-intercept first. And the y-intercept is when x is 0. And when x is 0, so that means our y-intercept is 2, and we know what our a value is. So our equation is going to be y equals 2 times, and now we need to find b. So the way that b shows up in the table, b is the multiplier, and it is how you get to the next term. So from 2 to 6, from 6 to 18, from 18 to 54, what are we multiplying by to go to the next term? Multiplying by 3, right? 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. So the multiplier is 3. Okay, and now we can finish our equation. Y equals, again, b is our multiplier, 2 times 3 raised to the power x. Now an alternate method to find the multiplier is you take the second term in the table, the y value I mean, which is 6, and then you divide it by the first value in the table, which is 2. So 6 divided by 2 is 3, so this is an alternate method to find multiplier. Divide second number in table by first. Alright, let's do another example. This time, let's write the exponential function equation given in the table below. This one's a little harder, but it starts the same. Let's find the y-intercept. And the y-intercept is when x is 0. And when x is 0, y is 0.02. So that's our a value. So our equation is going to be y equals 0.02 times, and now we need to find the multiplier. Okay, so let's look at the table. 0.02 times something is 0.01, and then times something else is 0.005, times something else is So this one's a bit harder. So let's actually go to the alternate method to find our multiplier. This is when the alternate method really comes in handy. So a reminder there is you take first number, you take second number, and you divide by first number. So the second number in the table is 0.01, that's our y value. So let's take 0.01, and let's divide it by the first y value in our table, which is 0.02. And you're going to need a calculator for this one, so let's get out the calculator. Okay, so we do 0.01 divided by 0.02. And we get 0.5, or a half. So that means our multiplier is 0.5. And let's actually double check just to make sure that this is the case. So if we then take, let's say, 0.01 and multiply it by 0.5, we should get the next number in the table. And we do. And then if we multiply by 0.5 again, we should get 0.0025, and we do. So our multiplier is correct, 0.5. And that's our b value. And it's raised to the power x. So that's our equation. Thanks.